Hello students, welcome to Spectra Education Academy. In this video, I'll continue explanation for previous NEET questions from the chapter Alternating Currents. Let us start with the first question. An inductor 20 millihenry, a capacitor of 50 microfarad and a resistor 40 ohm are connected in series across a source of EMF V is equal to 10 sin 340t. The power loss in AC circuit is, so this is given in 2016. Okay, so the power in AC circuit, equation of power in AC circuit. So two ways you can write. P is equal to, P is equal to V RMS IRMS cos pi. Otherwise, this can also be written as V naught by root 2 because RMS is maximum by root 2. IRMS as I naught by root 2 with cos pi. Separately, cos pi will be equal to, in two ways you can express in terms of resistance divided by impedance. So what is the impedance? Impedance is R square plus XL. XL is inductive reactance. XC is capacitive reactance. Okay. So let us also write this I naught in terms of impedance. So this is 1 by 2 because root 2 into root 2 is 2. V naught. Let us also write I naught as V by V naught by Z. Because according to Ohm's law, I is equal to V by R. So V naught by Z. So therefore, even there is also cos theta. So cos pi is equal to, you can write it as R by root over. So it is going to be R square plus XL minus XC whole square. Now even Z is also same. So root and root get cancelled. You can extend this 1 by 2. V naught square with R. Z is impedance. So what is impedance? Impedance is R square plus XL minus XC whole square into, there is one more impedance. So that is root over R square XL minus XC whole square. Since these two quantities are same, root get cancelled. So therefore, it is going to be 1 by 2 V naught square R by this quantity without root. So R square first XL minus XC whole square is equal to. So in the equation, EMF V is equal to V naught. So V naught is 10. So let us also find out XL and XC. So XL is equal to omega L. Omega is 340 because V is equal to V naught sin omega t. So comparing, omega will be 340. L is 20 millihenry. 20 into 10 to the power of minus 3. So this 0 get cancelled. So there will be minus 1. So this is 68, but there is 10 to the power of minus 1. So therefore, it will be 6.8. So XL is 6.8. Similarly, let us also find out XC. XC is 1 by omega C. Omega is once again 340, 1 by 340. C is 50 micro. So 50 into 10 to the power of minus 6. So if you cancel these two zeros, this will be minus 4. If you take minus 4 up, so it will be 10,000 divided by 34 into 5. So 5 2s are. So it will be 2000 by 34. 1 second. Let us continue further the calculation. So 2 tens are It will be 1017. So if you further this one, if you calculate further, so it will be approximately 58, roughly 58. 58 minus, so this will be 58. XC is 58. So let us come back to the basic equation. V naught is once again 10. 10 square is 100. R in the question is 40. Divided by R square, 40 square. So 40 square means what? 1600. Plus X L is 6.8. Minus this is going to be 58 roughly. So just you can calculate 58.6 something. So on subtracting this one, roughly you'll get 52. So therefore, this is going to be 4 with the 3 zeros divided by 2 into 1600. 1600. So there is again squaring. So 52 square. So already this is made squaring. So this particular part you need to square it. So therefore, so this is going to be 52 square. So on simplifying this, you'll roughly get. Yeah. So on simplifying this, you'll get this as 4000 by 8608. If you simplify it further, so you don't get the exact value. So roughly this is going to be 0.49. So the answer is given 0.51, but so make it calculation properly. So you'll get the answer. So this question approach of this particular question is similar to question number 5. Only numbers are different. So look at the question number 5. An inductor 20 millihenry. Even here also 20 millihenry. Capacitor is changed as 100 microfarad. Earlier it was 50 microfarad only in the first question. Resistance, they made it as 50. So earlier it was 40. So only values are different. So approach is same formula. Okay, so let us move to the second question. A small signal voltage V of t, so potential at any time, V naught sin omega t is applied across the ideal capacitor. See, so then, so current at any time in phase with voltage, current I at any time leads to the voltage by 180. Current I at any time lags the voltage by 90. Over a full cycle, capacitor does not consume any energy from the voltage source. So because it is ideal capacitor, so therefore it do not consume any energy from the voltage source. So last option is correct. Moving to the question number 3. Which of the following combination should be selected for better tuning of an LCR circuit used for? So based on the value for quality factor you get, so you'll have to write the answer. Quality factor, remember, 1 by R under root L by C. So each value you need to check. So first of all, if you check in which case quality factor is more, that will be your answer. So therefore Q is equal to, in the first case, R is 20, L is 1.5 divided by 35. So just you simplify this. This is the first case. Second case, quality factor 2, 1 by R. R is 25. Yeah, so under root L, L is 2.5 divided by C is 45 micro, remember. So capacitors are in micro. Then, so you simplify. So similarly, Q3, you go with 1 by R. So R is 10 under root. L is 3.5. R is 30 micro. Same way, you also go with the Q4. R is 1 by R. R is 25 once again. L is 1.5. C is 45 micro. So on simplifying this, you will get the result like this. In the first case, you will get a 10.35. In the next second case, you will get 9.47, 9.43. In the next case 22.77, and in the last case 7.3. So therefore, this value is more, so third option is correct. Moving to the next question, question number 4. The potential differences. The potential differences across the resistance, capacitance, inductance 80, 40, 100. So respectively in an LCR series circuit, power factor of this circuit. So remember, power factor is in general represented cos pi. So cos pi is equal to VR by root over, because since they mentioned potentials, if they mentioned resistances, it will be R by. If resistances are mentioned, cos pi is equal to R by root over R square, inductive reactance and capacitive reactance whole square. So remember the phasor diagram. So this is going to be VR. For in case AC is connected to resistor, both IA and potential are in same phase. In case inductor is connected to AC source, potential across inductor ahead of current by 90 degrees. In case capacitor is allowed to connected, potential across capacitor is lagging behind the current by 90 degrees. So therefore, net potential will be VL minus VC. So this is the basic idea. VR square, VL minus VC whole square. Just simplify this. Potential across resistance is 80. This is 80 square. So 80 square means what? 6400 plus VL. So VL is 100 minus VC. VC is 40 whole square. If you simplify it further, 80 by, so this is 6400. This is 100 minus 40, 60, but 60 square. So it will be 3600. So 80 by, this is 10,000. Root 10,000 is 100. So therefore, answer will be 0.8. So third option is correct. So the approach to get the answer of question number 5 and 1 is same. So therefore, you can skip that question. So moving to question number 6. A 40 microfarad capacitor is connected to 200 volts and 50 hertz supply. The RMS value of current in the circuit is, so remember, IRMS is equal to VRMS by XC. So this is VRMS directly, 200 given means that is VRMS only. So it is 200 by, so 200 by XC. Remember XC is 1 by omega C. So 200 with omega C. Omega is 2 pi frequency. So 200 with omega. So 2 pi F. F is 50. C is 40. 40 micro in particular. Minus 6. So there is a cancellation. 1, 2, 3, 4. This is going to be minus 2. So next term. This is going to be 20. 4 5s are 20 into 2, 40. 40 into 2, 80. 80 into 3.14. 80 into 3.14 with the 10 to the power of minus 2. So you can cancel one more 0. This is a minus 1. So roughly this value will be closer to, so 25, but 25 by 10. So it will be 2.5. So third option is correct. Moving to the next question. 7th. A series LCR circuit is connected to AC voltage source. When L is removed from the circuit, the phase difference. So remember, so tan pi without L. So without L, tan pi means you will have to write VC by So based on the phase diagram also you can understand. So this is the direction along which when resistor alone connected, IA and potential are in phase. So this is going to be VC. If pi is given here, So tan pi opposite. So opposite is VC, potential across capacitance. Adjacent will be VR. So even you can get, so they mentioned without inductance, phase is pi by 3. Pi by 3 means 60 degrees. So therefore tan 60 is root 3. This is equal to VC, let us write IXC by I into R. So I and I cancel. So XC is equal to root 3R. In the next case, if C is removed means once again, so this is the way to write the phase difference. So this is going to be pi, this is VL, this is VR. So therefore, once again, tan pi is equal to VL by VR. So therefore, tan pi is equal to, once again, it is pi by 3. So tan 60. So root 3 is equal to, so V into XL, I into XL by I into R. So XL is also equal to root 3R. So now let us write power factor. So what is power factor is cos pi is equal to R by root over R square XL minus XC whole square. So as per the question, we got XL equal to root 3R. Even XC is also equal to root 3R. So R by root over R square plus root 3R minus root 3R. This is a whole square. Since both the quantities are same, they get cancelled. So this is everything is under root. These two get cancelled. You will get R by R. R square root R. So R by R only. These two get cancelled. So it is going to be 1. Moving to the next question. An inductor of inductance L, capacitor of capacitance C, and a resistor of resistance R are connected in series to an AC source of potential difference V volts as shown in the figure. Potential difference across L and C and R is 40 volts, 10 volts, and 40 volts respectively. So the amplitude of current flowing through LCR series circuit is, so this is going to be amplitude, current amplitude. So I naught is equal to 10 root 2 amperes. So the question is to find out impedance. So to find out the impedance, so first let us write IRMS. So IRMS is nothing but VRMS divided by impedance. So I naught can also be written as IRMS can also be written as I naught by root 2 is equal to VRMS. So VRMS can be written as, so VRMS is nothing but V net. This is, understand that V net. So V net is nothing but VR square VL minus VC whole square divided by Z. So this is under root. Now, so I naught is 10 root 2 divided by root 2. Now VR square is 40. So 40 square means 1600 plus VL is 40 minus VC is 10, but whole square. So this quantity, entire quantity is under root divided by Z. So there is a cancellation here. Root 2 get cancelled. Then next, so let us simplify this first. 1600, this is 30 square means 900. So root 2500 divided by Z. So it will be 50 by Z. So Z is equal to 50 by 10. So Z is nothing but 5 ohm. It means last option is correct. Moving to the next question. A step-down transformer connected to an AC supply, AC mains supply 220 volts, is made to operate. So these are outputs. 11 volts and 44 watt lamp. So this is output side. So first let us find out what is the current output side. Ignoring the loss of power in the transformer, what is the current in the primary? So power out. is equal to V and I. V and I. So they mentioned in the question power 44. So this is output side. V is 11. So I outer. So this is 4 times. Now, since power remains same, so only there is at the input and output voltage change. Accordingly, current changes, but power remains same. So therefore, power out is equal to power in. Power out as V out and I out is equal to power in means V in, I in. So this is in means primary side. V out is 11. I out is 4 is equal to V in. V in is 220. I primary. So I primary this is. So therefore, so this is 11 into 44 by 220 is equal to I primary. So this is going to be 2 times, it will be 20. This is going to be 5. So current in the primary circuit is 1 by 5. Otherwise, this is 0.2 amperes. So first option is correct. Moving to the next question. Question number 10. Yeah, okay, there is an explanation required. A series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor, a 40 ohm resistor is connected to 230 volts variable frequency AC source. The angular frequency of the source at which power transferred to the circuit is half the power at the resonant angular frequency are likely to be. So there is a brief explanation. So this question is based on sharpness of the resonance. So taking current amplitude along y-axis, frequency along x-axis. So when you take 3 resistors, so this resistance is less, current amplitude will be maximum. This resistance is maybe medium, current amplitude will be medium. This resistance is more, current amplitude. But remember, at the 2 values of angular frequency, the current amplitude is same. So this is the basic idea to get a width. So first case is W2 is equal to, W naught. This is resonant frequency, W naught minus delta W. Because this is ahead, this is resonant frequency. Since this is ahead, so W1 is equal to W naught plus delta W. So therefore, so you'll get finally delta W on simplifying this everything. So this is delta W is equal to W1 minus W2. So you'll finally get substituting and making use of resonant frequency equation 1 by root under root LC. All that taking into consideration, you'll get delta W is equal to R by 2L. So you can verify it. So first we have to find out omega 1. Omega 1 is equal to omega naught plus delta omega. Then, so omega naught we have to look for. So omega naught is equal to 1 by root LC. Then, so 1 by L is how much? 5. C is how much? 80 microfarad. So 10 to the power of minus 6 under root. So this is going to be 400. So omega naught is equal to 1 by 400 into 10 to the power of minus 6, but within root. So this is 20 into 10 to the power of minus 3. So it is going to be 10 to the power of minus 3 means taking up, it will be 1000 by 20. So it will be 50. So therefore, omega naught is 50. In the first case, omega 1 is equal to 50 plus delta omega is R by 2L. So how much is R given in the question? 40. Divided by 2 into L. How much is L? 5. So therefore, this is going to be 10. 4 will be left. So 54. So maximum value is 54 and minimum value let us look for. So omega 2. Omega naught minus delta W. Therefore, omega naught is once again 50. This is once again 4 because this is only subtraction. So 4, it is going to be 46. So third option, this is the minimum value, this is the maximum value. Yeah, so where resonant angular frequency occurs. So third option is correct. Moving to the next question, 11th. The peak voltage of AC source is equal to, so IRMS is equal to I naught by root 2. So simple question, I naught is equal to root 2 to IRMS. Yes, so root 2 to IRMS. Root 2 times the RMS value of AC source. First option is correct. Moving to the next question. Yeah. Yeah. A series LCR circuit with inductance 10 Henry, capacitance 10 microfarad, resistance 50 ohm is connected to AC source of voltage. Voltage as 200 sine 100t. So this is omega. If the resonant frequency of the LCR circuit is V naught and the frequency of AC source is V, then so AC source frequency means omega naught, we have an equation root over LC. Otherwise, so since they are asking nu naught, so this is nu naught frequency. Therefore, angular velocity can also be written as 2 pi nu naught is equal to 1 by root LC. So nu naught is equal to 1 by 2 pi root LC. How much is L? 10. How much is C? 10 micro. So 10 micro means 10 to the power of minus 6. This is root 100. It will be 10. 10 to the power of minus 6 root means 10 to the power of minus 3. So 1 by 2 pi into 10 into 10 to the power of minus 3. So therefore, this is 1000 divided by 10 into 2 pi. So this is going to be 0. This is going to be 50. So 50 by pi is the resonating frequency. Now let us also try to find out, let us try to match the frequency of the source. Will it be matched or not? So nu is the frequency of the source. So frequency is equal to 2 pi omega is equal, as per the question, in the question V is equal to, they mentioned 200 sine 100t. So on comparing, V is equal to V naught sine omega t. So omega is equal to 100. Omega means 2 pi with the frequency of the source nu is equal to 100. So therefore, frequency of the source nu is equal to 100 by 2 pi. You'll once again get 50 by pi. So therefore, this particular equation having the frequency which is matching to the resonating frequency. So where current amplitude will be maximum. Moving to the next question. Yeah. An inductor of inductance 2 millihenry connected to 220 volts with 50 hertz AC source. Let the inductive reactance in the circuit is X1. So it means X1 is nothing but XL. If 220 volts DC source replaces the AC source, then the inductive reactance in the circuit is, this is when AC is present, AC source is present. X2 is equal to XL when DC source is present. Then the inductive reactance is X2. So X1 and X2. So we cannot operate DC source because DC source does not alter. So there is no change in the magnitude, no change in the direction. So AC is nothing but if whose magnitude changes with time and direction reverses periodically. So then only there is a frequency change possible. So here with the DC source, we cannot find out XL. Then next, moving to when AC source connected, XL, let us find out. I is equal to, we need to find out XL. So XL is equal to omega into L. Omega is nothing but 2 pi with F with L. Then, so F is 50, 2 into 3.14. F is 50. L is, how much is L? Yeah, L only you need to find out. Yeah, XL you need to find out because L is mentioned. 2 into 10 to the power of minus 3. So 0 cancelled, minus 2. Then 2 2s are 4, 20. 20 into 3.14 into 10 to the power of minus 2. So this is going to be minus 1. This is going to be 6.28 with 10 to the power of minus 1. So altogether there is 0.628 amp, 628 ohm XL. So third option is correct. So you don't get XL when DC source is connected. Moving to the next question. A standard filament lamp consumes 100 watt when connected to 20 volts AC main supply. So the peak currents, I naught they are asking us to find out. So whatever 200 is given, that is IRMS only. So first let us find out IRMS. IRMS is nothing but VRMS. Yeah, so let us try to find out because power is mentioned, potential is mentioned. So let us write power is equal to V into I. So you'll get IRMS only here. So IRMS is equal to P by VRMS. P is 100. V is 200. So it will be 1 by 2. But the question is maximum peak value. So it means IRMS is equal to I naught by root 2. So this is going to be IRMS is 1 by 2. I naught by root 2. So you'll get this as I naught is equal to root 2 by 2. Otherwise, this can also be written as 1 by root. So 1 by 1.414. Approximately, this is equal to 0.707 amperes. So first option is correct. Moving to the next question. This is question number 15. In a series LCR circuit, the inductance L is 10 millihenry, capacitance 1 microfarad, and resistance is 100. So the frequency at which resonance occurs. So frequency is the question, but omega is enough to find out. 1 by root LC. So we don't require the value of R here. Omega naught. So 1 by root L. L is how much? 10 milli. So 10 into 10 to the power of minus 3. And C is 1 micro, minus 6. So you can cancel 1 0. So this is going to be minus 1. So therefore, this is 10 to the power of minus, this is 2, sorry, minus 2. So 10 to the power of minus 8 altogether. Root 10 to the power of minus 8. Then this is going to be 1 by 10 to the power of minus 4. Then, yeah, since frequency may be the question, let us look at this. So 2 pi f, let us also write 2 pi f. So let us find out angular frequency first. Because we are going to find out frequency, not angular velocity. So we have another provision, angular velocity is equal to 2 pi with the frequency. This can also be written as a 10,000. So F naught is equal to 10,000 by 2 pi. So it is 6.28. If you simplify, this is going to be 1590. So this is going to be 1590. So this can also be written as 1.59 kilohertz. Moving to the next question. A 12 volt and a 60 watt lamp is connected to the secondary of a step down transformer whose primary is connected to AC mains 220 volts, assuming the transformer to be ideal. What is the current in the primary? Already we got one question. So we need to find out current in the primary, I primary. Question mark. So first thing is power at the input is equal to power at the output. V out, I out is equal to V in, I in. So we are looking for I in. So I primary means I in only. Now let us try to find out I out first. I out is equal to power by voltage. voltage out. So secondary given means it is out. So 12 by, sorry, P is 60, V is 12. This is going to be 5. Now V out is 12. I out is 5 is equal to V in is 220. I in or I primary we are looking for. So I primary is equal to 60 by 220. 0 cancelled. 6 by 22. So roughly is equal to 0.27. You can verify it. Moving to the next question. Probably this is the last question. The net impedance of the circuit. So this is 23 question. Net impedance, get back impedance equation. So it is in terms of resistances only. XL minus XC whole square. So how much is R? 10. So it is 10 square. XL directly millihenry given. Yeah. So 50 by pi with 10 to the power of minus 3. Then this is going to be minus. So 10 cube by pi, but micro, minus 6 whole square, but root. If you simplify this, you will get the answer as pi root 5. You can verify it. Very simple. So this will be minus 3. Then look at this. So it is going to be 10 square plus 50 by pi with minus 3. This is going to be 10 to the power of minus 1 by pi, 10 to the power of minus 3 whole square. So this is after you take pi common, 10 to the power of minus 3 common within the root. So it is going to be 10 square plus 50 by pi common into 10 to the power of minus 3. You take common 10 to the power of minus 3 by pi. 10 to the power of minus 3 by pi. Enough. With the 50 minus 1 whole square. The root. So this is going to be 100 plus. This is 10 to the power of minus 6 by pi square with the 49 square. Simplify, approximately you will get pi root 5. Plus frequency is not mentioned, so we need to take this itself is XL. Students, in my next class, I'll continue explanation for questions, previous NEET questions which are given in electromagnetic waves. Thank you very much for watching my video. But don't forget to share and subscribe with your friends and relatives. Thank you very much.